Hello, everyone. As some of you know, we had internet trouble, or I had internet trouble yesterday. Zoom just decided to stop working in the middle of class. So, this is the recorded section that we would have done in the last hour. So, to start with, we actually talked about this during class, but when we talk about functions, there are parent functions, which are functions that we go to a lot. And so for right now, I have listed 8 of them, which is generally the ones that we use. And so you can see that we have here x, or y equals x. It's a straight line with a positive slope. We have y equals the absolute value of x, which looks like a v. We have y equals x squared, which is a parabola opening up. Y equals x cubed, which is this little kind of hump, and y equals 1 over x, where they kind of come close to the origin and then bounce back. And then y equals 1 over x squared, where there's nothing here in the bottom part of the y-axis. We just have two functions, or two lines that are, or two parts, I guess, that are coming towards the y-axis. And then we have y equals the square root of x, which this one has a domain restriction. If it didn't have a domain restriction, we'd keep going over here like that, and it would look kind of like a C. But that's not an actual function because it doesn't pass the vertical line test. And so it's just the top part of a parabola on its side. And then y equals the cube root of x is this function turned and reflected, I guess. And so it kind of looks like an S. So the first part that we're talking about is going to be reflecting a function. In class, we talked about reflecting a point, but now we're going to be going into transformations for functions, which for right now is going to include reflecting and shifting left and right and shifting up and down. So here we have our parent function, which is y equals x squared, have that parabola. And when we add a negative, so when this negative is added to the function, then it impacts our base function by flipping it about the x-axis. So it's a reflection about the x-axis. And so instead of opening up, negative x squared would open down. And that's going to happen anytime we add a negative to the outside of our function. So even if it was a different base function, like x squared, or well, we have x squared, but x cubed, it would reflect across the x-axis. Now we're going to talk about how to move a function up or down, which is a vertical shift. And so in this situation, we don't have a negative because we're not doing any reflecting about the x-axis. Instead, the difference is that we've added this plus 2. And the plus 2 has been added to the end of the function, although technically, as long as this x cubed stays all together under the commutative property, you could write this a different way. But if we start with, in this case, a parent function of y equals x cubed, you can see that the normal function would go through the point 0, 0. But when we take x cubed and then we do this plus 2 at the end, it takes our original function and it shifts it up 2 units. It's going to shift it up however many this number is. And so that's what it says on the bottom. If you add a positive number to the end of the equation, again, we said that that could change a little bit depending on how you write the equation, as long as you stick with the commutative property rules, then adding a number is going to make it shift up. And so if we're thinking that adding makes it shift up, then it would make sense that subtracting would make it shift down. So here we have that same parent function, and it's back to going through 0, 0. But when I add right here my subtracting by 2, or you could say plus negative 2, then my function is going to go down 2 units. So subtracting at the end moves the function down, adding at the end moves the function up, and that would be our vertical shifts. Now, the next part that we have is shifting left or right, and shifting left or right is a little tricky because it's the opposite of your instinct. The other part that's important about shifting left or right is that it has to be included with whatever your x term is. So notice here, when we included a 3, a negative 3, it stayed with this x part, and so our square root sign was extended. So if I have a base function or a parent function, which for this one I chose y equals the square root of x, then if I do y equals the square root of x minus 3, my function is going to move 3 units to the right. So instead of having this 0, 0, now it has this 3, 0. But again, remember that not only does it have to be grouped with the x, but it's also the opposite of what you would expect. A negative is going to move it to the right, whereas a positive is going to move it to the left. So I'm going to move my graphs over here a little bit. So here I start again with my y equals the square root of x, and now I want to move it to the left 3 terms and 3 units. So I have this plus 3 again under my square root or my radical symbol. But when I have a plus 3, it moves my function 3 units to the left. So again, pay attention because this is the opposite of your instincts. And actually this is, I just noticed a little error. This should say a positive x moves left. And so we have this as a little recap. In your book, these are the tables that they present, and they added using h and k, which is something that we will talk about eventually. But they said make sure that you have this constant and that it is a positive number. They define that in both situations. I added that if you wanted to use a negative number, you'd have to do plus a negative number. But so if you want to move left or right, I think that's the hardest, then remember you have to do the opposite and it has to be grouped with the x. So in this situation, they're taking x minus h, and minus h moves to the right, and plus h is going to move to the left. If we want to move up or down, we're going to go outside of this x term and add to the end a plus k to move up and a minus k to move down. And if we wanted to reflect about the x-axis, then we're going to add a negative in front of the function as it's written. To add on to this with a slide that I don't have but was in your practice, you can also make the graph shift to be, or scale to be bigger or smaller. And to do that, you multiply the whole term. So instead of this negative sign, you'd have a number here. If you want it to get narrower, you would multiply by a whole number, like 3. And if you wanted it to get wider, you would multiply it by a fraction, like 1/3. So if I'm given a function and they tell me this function has been transformed, or maybe they don't even tell me that, then I should be able to know what moves happen to that function without actually graphing it, although I do always have the option to graph. But when I look at this first function right here, I'm just going to go from the left to right, and I'm going to say, well, first of all, this is based off the parent function, y equals the absolute value of x. Again, you could start with any parent function. I gave lots of examples here, but they follow the same rules. So 2y equals the absolute value of x. I'm going from the left to the right. The first thing I see is a negative sign. The negative sign means that I have an x-axis reflection. And so whatever graph I normally have, I need to flip that over the x-axis. A lot of times it looks like it's upside down, depending on the symmetry of the function. And then I'm going to notice this part in the parentheses, and grouped with my x is a +5. And so that means it's going to be a left or right move, and it's going to go 5 units. But this is the one that's tricky because it's the opposite of your instincts. So adding 5 is going to make this function shift 5 units to the left. And then the last thing I'm going to see is I have this +6 at the end of my function. And so since it's kind of on its own, that means that my whole function is going to shift up 6 units. So I've got my reflection, my leftward shift, and in this case, my upward shift. We can see that on these graphs. This would have been what my original parent function would have looked like, where I have y equals the square root, or the absolute value of x, which looks like a little v and has this 0.00. But after the transformation, you can see where the v was pointing up, now it's pointing down. That's my negative sign on the outside, or my x-axis reflection. Instead of having a point at 0, 0, my point here has moved over to the left 5 units, which is where this comes from. This +5 has made my function move to the left 5 units. And then my point is also up 6 units, which I can see right here. So you should use Desmos and kind of play around with it a little bit, going back to your parent functions so you know where you're starting from. But in general, you should be able to move that function up or down by adding or subtracting at the end, flip it around the x-axis, which you can do by adding a negative to the outside, or moving the function left or right. But again, pay attention to left or right. It has to be grouped with the x, and positive number moves it to the left, and if this were a negative number, it would move it to the right. I hope that this has added some clarity. There is an assignment on D2L under surveys that lets you kind of play around with this a little bit and answer some questions. And it's also the participation points for July 2nd's class. I hope you all have a wonderful weekend, and thanks for listening.